Hi guys, it's Mr. Salama, and I'm going to go through question 16 part B from the extension 2 HSC paper 2018. As you can see, the question is right in front of you right now. I want you all to sort of look at the key information provided in the question. That's going to help us obviously achieve what we're trying to look for. Obviously there's a lot of ratios here. BC to D is the square root of 2. Also CA over FG is also the square root of 2. BA over HI is also the square root of 2. Okay. Look, there's a few things that we can't assume. We can't assume because everything is in the same ratio. Some people think we're dealing with two equilateral triangles. Okay. That's not the case. Also, because in this particular question, I was told that this side there is parallel to this side is also parallel to this side, and last but not least, this side of the triangle is parallel to this side. Okay. A lot of people started off by trying to find out if these angles are the same, and they spent a lot of time finding all the different angles. That's going to eat up a lot of your time, so that's not what we're really after here. So once you read the question once, twice, understand the data that's given to you in the question, so the ratio of the different sides being the square root of 2, parallel lines, then we can start attacking the question. So the first part is saying, can we somehow prove that dy is equal to ZE? That's the first section that I'm going to look at. So what I'm going to do, I'm going to start off by obviously listing a few things. That's very, very obvious. And that is the fact angle ABC is equal to angle IHC. Reason, corresponding angles, and angle BAC is equal to angle HIC. Reason, same thing, corresponding angles. Putting these two together, you've got two triangles. In these two triangles, two of the angles are the same. Therefore, by the definition of angle sum of a triangle, we know it's 180 degrees. Therefore, the third angle must be the same. So we are looking at two similar triangles. Reason being equiangular. Now, if I wanted to draw these two triangles separately, I'll probably do it for the first example, for the first part. So we have triangle A, B, C, triangle I, H, C. Now this angle and this angle are the same, we'll prove that, and also this angle up here and this angle also the same. So now, since the two triangles are similar, then the sides must be in the same ratio. What does that mean? It means that BC over HC. Now looking at this BC over HC, I can't tell you what BC over HC is equal to because it wasn't given to me in the question. There was nothing mentioned there that the fact BC over HC is equal to something. It wasn't mentioned. However, BC over HC is the same as BA over HI. And that was given to me. BA over HI, which is equal to the square root of 2. So, don't forget, keep this in the back of your mind because we're going to come back to this later and use it. Okay, so that's what we have so far. So, if I continue with this, again, different triangle. So, let me try to paste this in. Okay, here we go. Just the diagram that we had before. This time I'm going to look at the following angles. I'm going to look at angle ACB, which is equal to angle GFB, and angle CAB equal to angle FGB, and the reasons for both corresponding angles. Okay, now same situation as I mentioned to you before. Two of the angles are the same in both of these triangles, therefore these two triangles are similar. So we can say that triangle ABC is similar to triangle GBF, and reason being equiangular. Having said that, we can make this, again, this statement, because the sides are in the same ratio, therefore BC over BF, okay? Again, there's no value for that, but BC over BF is the same as AC, so hang on, let me see, BC over BF, same as CA, just put AC for now, over FG. Hopefully the letters are not the other way around. Okay, equal to square root of 2. So that's also another result that I am going to make use of. So don't forget that either. So far, let's see. Did I mention the... No, I didn't. So I better write this here as well, that these two triangles are similar as well in the first part. Triangle. Sorry, I'm running a bit out of room here. So, but triangle ABC is similar to triangle IHC. So I should have said that before. And based on that, that's why we have these ratios equal to the square root of 2. So now we made this statement again by using two different triangles to basically equate them to the square root of 2. And as you can see, there's a what's happening is we're trying to find what else is equal to the square root of 2, because if I know they're equal to the square root of 2, I can equate them to each other. Okay, so now using these two things that we mentioned, that BC over BF is equal to AC over FG, which is equal to the square root of 2, and previously BC over HC equals B over HI equals the square root of 2 as well, I'm going to say this. I'm going to say the fact that now BC over BF is equal to BC over HC. Now, remember where I got this from? From this part here, which I highlighted for you, and the second part as well. Now, keep in mind, we've done this before. If I have 1 on X equal to 1 on Y, this follows X is equal to Y. Okay? So that's very important. Of course, X and Y cannot equal to 0. Okay? Having said that, therefore, BF must equal to HC. Now, what is BF? Okay, let's look at this carefully. In actual fact, BF, people, is BH plus HF. Okay, and HC is HF plus FC. Now, BF, HC, they're equal to each other. So we can say that BH plus HF is equal to HF plus FC. So that's what I'm going to write here. I'm going to say that BH plus HF equal to HF plus FC. Now, very obvious, HF, therefore I'm left with BH equal to FC. Okay, so that's done. So now BH is equal to FC. Where's BH and FC? Well, I can make this section, BH, equal to this line there, which is the FC. That's what I'm referring to. Now, remember the question was asking not for BH and FC, but it was asking for DY and ZE. Okay? So therefore, what I need to do, somehow, if I can prove that dybh is a parallelogram, then guess what? Opposite sides of a parallelogram are equal. So that's going to, dy is going to equal to bh. And if I do the same thing on the other side, fcez, prove it's a parallelogram, therefore fc is equal to ze. And since bh and fc are equal, by definition dy is equal to ze. So that's what I'm going to do. So I'm going to say AB is parallel to IH and BC parallel to DE. Okay? Therefore, BDYH is a parallelogram. Okay? Which means BH is equal to dy, as I mentioned a few seconds ago. Okay, looking at the other side now, AC parallel to GF and BC parallel to DE. Okay, then FZCE is a parallelogram. I'm running out of room. I'm sure I can make it. That is FC equals ZC. So now, let me repeat. We proved initially that BH is equal to CF. That's what we proved. Then we proved that BH is equal to DY because they're part of a parallelogram, opposite sides of a parallelogram. Then we did the same thing on the other side. We proved that FC is equal to ZE, again, opposite sides of a parallelogram. Therefore, once you've done all that, we can try to put it here in a nice box. dy is equal to ZE. Very easy. Okay, so what I'm going to do, I'm going to make a different video to answer the second part. Okay, see you soon.